In this video, for Chapter 11, Section 5, we're going to explore solids. So the first type of solid we're going to talk about is a polyhedron. And a polyhedron is a solid that's bounded by polygons called faces. Each polyhedron has edges and vertices. The edge is a segment that is formed by the intersection of two faces. The vertex is the intersection point of three or more edges. So the plural form of a polyhedron is polyhedra or polyhedrons. So down here in my figure at the bottom of my slide is a picture of a polyhedron. And this is actually a trapezoidal prism. Now, what you're going to be looking for is the shape that you see two of. And the shape that you can see two of is called the base. Now, your polyhedron may not be sitting on its base, so what you need to locate is what you have two of. So let's first identify where the vertices are located. And the vertices are, again, the intersection of three or more edges. So I'll go ahead and label some more vertices here. You have them in red, and this is where the three or more edges meet. So we have all of these edges. All of these vertices. So this actually has 8 vertices. Now, let's go ahead and identify where the edges are. And I can go ahead and I will go over the edges in green. So the edge is a segment that is formed by the intersection of two faces. So this would be an edge, another edge over here, here, along the front, over here, the dotted ones that are behind where we can't really see, at the back, and then around the top. Now the faces are the polygons. So we have a face here, and then we have them on the side, in the back. All of the polygons that form the sides are called the faces. These are different types of solids. So we actually have polyhedra and non-polyhedra. Notice the polyhedra, their sides are all polygons. The non-polyhedron, they have curved sides, and their sides are not polygons. So a cylinder, a cone, a sphere, they all have curved sides, and these would not be polyhedra. However, prisms and pyramids are polyhedra. Let's now discuss prisms. So to name a prism, we're going to use the shape of the base. And the bases are usually the top and the bottom. Now, just be careful, because sometimes in the homework or on a test or a quiz, your prisms may not be sitting on the base. It could be sitting on its side. So what we're looking for is whatever we have two of, and that would be the shape of the base. The lateral faces are the parallelograms that are formed by connecting the corresponding vertices of the bases. The altitude or height of a prism is the perpendicular distance between its bases. What we're going to be looking for whenever we look for the height is we're going to be looking for a right angle, because it's going to be the perpendicular distance. Then the two bases are going to be the two congruent polygons that are in parallel planes. So like, for example, if I talk about the classroom, an example of parallel planes could be the ceiling and the floor. And in the classroom, it could be, they would have the shape of a rectangle. So those would be my two congruent polygons, and that would be the ceiling and the floor. I could also talk about the front wall and the back wall. Those would be parallel in parallel planes, and even the two side walls. In my figure here, this is a pentagonal prism. Notice the shape that I have two of. I have two pentagons, and my bases are pentagons. And in this particular figure, they've drawn it where the bases are the top and the bottom of the figure. Next, we'll talk about pyramids. And a pyramid is going to be named by its base. So its base is a polygon with n number of sides and n number of lateral faces that meet at the vertex. The altitude is going to be the segment from the vertex perpendicular to the base, which is also known as the height. So for example, if I wanted to draw in the height in here, it would be the perpendicular distance. And it would go from the vertex down to the base. And again, to name the type of pyramid, we're going to name it by the shape of the base. So the shape on the bottom here would be the base, and then the triangles would be the lateral faces here. And then these sides that come down here, these are the lateral edges. Again, this is a vertex. I also have additional vertexes down here. And again, your base shape, in this case, it looks like it's a rectangle. So we could say that this is a rectangular pyramid. Now, if they showed us that all the sides were congruent, let's say they put congruent marks here, then we could say that this is a square pyramid. Next we have Euler's theorem. And Euler's theorem is just a way to confirm that we've counted all of our faces, edges, and vertices correctly. So the theorem states that you would take the number of faces plus the number of vertices, and that will equal the number of edges plus 2. So in my figure here, this looks like it's a cube. So let's go ahead and let's count how many vertices we will have. So we have 1, 2, 3, 4, 5, 6, 7, 8, and that's what's written here. I have 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges, and then the faces are the polygons along the sides. So I have a face here, got another one over here, 2, 3, 4, and then the one in the back, 5, and let's see, the two sides, and then the top and the bottom. So I have the top, the bottom, the left side, the right side, and then the front and the back. So I have 6 faces. So if I take faces plus vertices, it's going to equal edges plus 2. So 6 plus 8 is 14, and 12 plus 2 is 14. So we did count the correct number of faces, vertices, and edges for this polyhedron. Next, they're asking us to identify to see if this solid is a polyhedron. If it is, they want us to name it. Then we want to find the number of faces, vertices, and edges. So let's first see if figure A is a polyhedron. Notice there are no curved sides. So yes, this would be a polyhedron. So yes, it's a polyhedron. So because it's a polyhedron, we need to name it. Notice the congruency marks along the base down here. This tells me that my base shape is a square. So again, to name our polyhedron, we're going to use the base shape. So this is a square pyramid. So because it's a polyhedron, we're going to count how many vertices we have, how many faces, and how many edges. So let's go ahead and we could do the number of faces first. So we have one base, which is a square, and then we have the 4 triangles up at the top. So we have 5 faces. Next, we're going to count the number of vertices. The vertices are where the 2 edges meet. I have 4 vertices on the bottom and 1 up the top. So I have 5 vertices. Next, we'll count the edges. Edges, here's 1, 2, 3, 4, 5, 6, 7, 8 edges. So let's go ahead and let's use Euler's theorem to double check that we did count the faces, edges, and vertices correctly. So remember, Euler's theorem states that it's faces plus vertices equals edges plus 2. So faces plus vertices equals edges plus 2. 5 plus 5 is 10. 8 plus 2 is 10. It checked out. We did count correctly. The next shape, the next solid that's in part B, notice we have a curved edge here, making this not a polyhedron. Then for figure C, notice there are no curved sides, so we're going to say yes, this is a polyhedron. And we're going to look to see what we have 2 of. And notice we have 2 triangle faces here. Notice it's not sitting on its base, but this is a triangular prism. And more specifically, notice the right angle here. So this is actually a right triangular prism. So because it's a polyhedron, let's go ahead and count the number of faces. So we've already determined that we had 2 triangle faces, and then I also have 3 parallelograms, or it looks like 3 rectangle faces. So that gives me a total of 5 faces. My vertices, I have 1, 2, 3, 4, 5, 6 vertices. And now for edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 edges. So let's go ahead and confirm that we did count correctly. So remember, using Euler's theorem, we're going to go ahead and do faces plus vertices equal edges plus 2. 5 plus 6 is 11. 9 plus 2 is 11. We did count correctly. Next, we're going to talk about a cross section. So a cross section is the intersection of a plane slicing through a solid. So in all of the pictures that are in the notes, my cross section will be the purple. Now, when you're doing the homework or doing this on a test or a quiz, it's going to be in black and white, so it'll be the piece or that's shaded a little bit differently. So my polyhedron here is in blue. It's a pyramid, and the figure that's creating the cross section is the pink plane. So when that pink plane slices through the pyramid, the cross section, if I were to pick up that piece that it cuts off, would be a triangle. So again, the cross section in the notes, all of those polygons that is created is going to be in purple. Now, depending on where the slice occurs, you can get different shapes from the polygon depending on the location of the slice. So for this particular cross section, the shape here is a triangle. Let's go ahead and see if we can identify what the shape is being formed by the intersection of the plane and the solid. So they want us to describe the cross section. So I know I don't have any congruency marks here on figure A, but let's go ahead and I'm going to tell you that this shape is a cube. So if my original shape before it has been intersected by the plane is a cube, then I now know that that purple intersection is going to be a square. Now in B, it's still that same cube, but now the intersection's in a different place, so they're slicing it differently. But notice this time the purple shape here is now a rectangle. So notice you can have the same polyhedron starting out, but when you slice it differently, you're going to get a different polygon. And now here in C, this time it looks like they're trying to slice off part of the side and the corner or the edge, and this time our intersection is a trapezoid. And now it looks like they're trying to cut off the corner here, and again the purple shape or the cross section is a triangle, and now they're intersecting a cone and a plane, and this cross section is a circle. So that is it for identifying the different types of solids and being able to name them based on their base, and then also being able to count the number of edges, faces, and vertices, and then using Euler's theorem to confirm your count. The homework is on Canvas. Now remember, you need to turn in your completed notes. It is an assignment on Canvas, and then once you've finished the notes and turn that in, you're going to go ahead and watch the notes for Prisms. The homework for 11.5 is combined with the next set of notes that you need to watch, which teaches you how to calculate the surface area of prisms and pyramids. So again, you're going to watch the video for the surface area, complete the notes, turn in the notes, and then you can complete the homework assignment. All 3 assignments are on Canvas.